So let's wait a little bit until everyone joins us and then we'll start. Okay, we can start. Hello everyone, welcome to today's session. First of all, thank you to those who shared the repository with me. So you can now share your home tasks with me in case you have had any issues with the setup. Please let me know, and I will try to help you. Yeah, I will definitely help you. In case you have any issues with the setup in your local repository, in your ecops, or your remote repository, so please let me know. That's about the setup, because there you will share your home tasks with me, and you will need to have this ability to share the code with me. Yeah, and I also mentioned that you also need to share the print screen of the unit tests completed, unit tests done. You can place basically how you can do. You can just can do the screenshot. Just a simple screenshot, then create the picture of it with the screenshot, and then you can simply place it under the same activity where it is done. Just like a moment, I will quickly share you. Okay, maybe I can do it this way. So here I run the unit test. It's running. Different stuff. Okay, it's running out of it. It's still running. Close some options on my computer. Okay, 5 minutes. Approaching. And yeah, so we have the result of the unit test. So you need to create a screenshot. This one. So you can save it. Somewhere here, and then just drag and drop it. This one, copy the files. Then it should be here. It should also be staged. And do the bit if I select here. I can attach it here and then just simply push it with the changes. Yeah. With the changes, and after that, it should be available in the remote repository. This one. No, sorry, this was not mine. Oh, yeah, no, that's correct, sorry. That's correct. So here I have the comment here. You can see the comments. If I go to source and create a folder and just put the file in, and here I can see this picture, and just can see that the unit test is how the unit test is executed. Right, so this is the way how you can attach the results of unit tests. Yeah, that's it about setup. In case you have any questions, please let me know how you need to proceed. Yeah, and so let's go with the schedule, with the agenda for today and tomorrow. The plan is that today we finish with Java syntax, and then we'll take one practical assignment. This is black light, and then this will be one assignment. And after that, most likely tomorrow, we will do we'll start talking about object-oriented programming topic, and also tomorrow you will have individual work. It's like I think that will be, so currently we have 5 hours planned for tomorrow. I think we'll have just usual 3 hours. We have 3 hours for the session from my side, and then I will leave you doing the individual work with the home task. I will assign the home task for you, so the deadline will not be the end of today or tomorrow, but you can start doing it tomorrow, and then as usual you can contact me in case you have any questions. But yeah, this is how it's planned for today and for tomorrow. Right. So this is about agenda. So agenda, and let's start. Let's continue with the details of the syntax. So yeah, in Java we have, as you know, we have variables and literals. A moment. Okay, yeah, one thing asked by Lemma, can we can I write somewhere all the things to be done? Okay, that's a good idea. I will. That's a good idea. I will share. I will share it here under. Maybe I will create a new text channel here. Yeah. So create a new text channel, and I will put the key things, how and what should be done. Basically the tutorial how the home tasks should be to be submitted. So I'll name it as guides, guideline. That would be, and I will write. I'll write the guide for the home task. So I'm going to provide the guide here in Discord. So for the home tasks, you need to submit I will also put the deadlines of the home tasks here as well. So you can, maybe I can name it as home task in this channel. Home tasks. And maybe after the lesson today and tomorrow I will provide the guides what should be done, and maybe some advices, something that can be helpful for you. And how you need to things. I will put the guideline here most likely tomorrow. Under the channel home tasks. So we will use this channel for just to have the information, to store the information about the home tasks. Thanks for this is a good idea. Okay, so we'll proceed this way, and right now let's continue with the syntax. So as you know, in Java we have two types of let's say not data storage, but in some way we can name it as data movement. We can store basically the place where the data can be stored during the execution of the program. So there are two ways, let's say two groups of places we can store the values in the system. These are the variables and the literals or constants. Just think to understand at this point. I'd like to stop maybe a little bit and explain you the things I would like you to know to distinguish. We have the variables, basically the data. The data we're working with. So as those who worked in the previous course, you know that we have the databases, and we also work with the databases. So we fetch the data from the database, we change the data there, and so on. So in this case, we store the data in the database. This is one place of the data, and and we have the variables and the constants. In this case, maybe there won't be much theory here, but just to think about when you work with the data, where the data is stored. Is it the database, or is it the program? Then these are the variables and constants. In practice, this is really important to understand where the data you use is stored. Is it the database, or is it your program? So it means that it's stored under the variables and the literals. Because it's really important, because if you work with the data, so first we need to understand where you store the data during your program. Like if you use it 20 times in your program, then you should not just access the database 20 times, right? you can access database once and then store the data in the variables and then just work with this data. That will increase the performance, and everyone will be happy here. Yeah, but in case you just you don't use the data more than once, then just once selected it from the database, show it somewhere, and then do nothing. Then yeah, you maybe will not need to find the right place in the program to store it. Yeah. So in this case, the variables can be used to basically the variables are used to store the data during the execution of the program. So this is the important thing to understand the concept of data storage. Yeah, because we have bufferizing, so-called, and buffer means that we are in our code, and so the data is stored in our program, and we work with it, comparing to the database. So in Java we have two types of this way of data storage, exactly in the program. So these are the variables and the constants. There's one difference between them. It is that the variables can be changed. So you assign it once, and then you can change it multiple times, as many times as you want. And then we have the constants, which you can which can be assigned only once, and you will not be able to change them. Just for example, in Java, there are inside code there's literally we find constants like numbers, and these are not the variables, these are the constants. So in fact, these are the constants as well, because we cannot change the values of them. Yeah, and regarding naming conventions, which are, as I said, quite important in Java. In Java, we name the variables in lowercase. So we start with lowercase, and then we use so-called camel case. It means that to separate the words, we can separate them this way. Like we start with the letters in lowercase, so all the letters are in lowercase. Then when we go to the next word, then we start with uppercase, and then if we go to the next word again, then we also use uppercase letter then. Yeah, so no more strict restrictions here on the naming for the variables. Just in case you want to think about how you name your variable, then just use this approach. Yeah. And actually, for the constants, constants usually are named in uppercase. So everything is in uppercase. All the letters are in uppercase, and the words are separated using the underscore. And by definition, variables are defined in the way that we have the type, we provide the type, we provide the type, then we provide the variable name, and if needed we assign the value. For the constants we have the same way. For definition we use final, so it means that this is the final, this variable has the final value, and you can assign it directly during the definition, or you can define it like final and type and name, and then you will be able to change the value, not to change but to assign the value only once. So once it is assigned, after that you will not be able to change it. Usually the constants are the values to the constants are assigned in the constructors or just directly on the definition. Two ways, and maybe the question from you may be, where do we need to use the constants? Just so like so if I just can use the variables, why do I need to use the constants? That's the question mostly related to the style of programming, and to point again, the program is on practice we usually do not only write the program to deploy the work, like we build some kind of software, and then the software just works in the way we built it. That's partially true. That of course we developed to create something, to create some software, to create some web pages and so on. But the also another really important criteria, and maybe not less important, but maybe even more important, is that we write the code so others can also read it. So it means that we provide our legacy to one particular program, and then this program will be read by other developers in future. And that's why, since we write the program, then we must point on the things we try to achieve in our code. Otherwise, if we just create the code by our own without any rules, then others will not understand what did you mean 10 years, not 10 years ago, but 2 years ago maybe. Then others will not understand. And constants is one of the ways that can help other developers to read your code. So if you declare the constants, it directly points to the developer that this is the constant, this variable will not be changed. And usually how do we use the constants? We use them in the way that this is the that's makes sense that this is the variable which this is the value which will not be changed. Some examples, maybe you have the list of products, and then you have fixed type of the products. Again, that's maybe imagine every product. Maybe the ice cream, then you will have several flavors of the ice cream, like lemon, chocolate, vanilla, and so on. Then just in the code, to not hard code it every time. Like you may use these values several times, like 5 times, for example. So it means that you have these three constants, and so it means that you have these 3 flavors: lemon, chocolate, vanilla, maybe strawberries, or 4 flavors, and then you use them in the code. You use them pretty same way, and maybe you use them all these 3 flavors, let's say, in 5 places, for example. Then imagine that you need to change the value of one or several of them. Then what you need to do, you will need to change these hard-coded values in 5 places. But if you use the constant, so it means that the same constants are used in 5 places, so you just need to change the values of the constant, and this will solve you this issue. That's about constants. Basically, usually the idea is to not hard code the values inside them. So it means that you declare the constant, and by the name of the constant, in fact, I can understand what is meant by value 10. Because usually, so let's say, if you use something like that, maybe. So you type string, let's say type of something. Okay, it doesn't matter what is the type, and you name the type is ABA, maybe something like that. So when you assign this value, just maybe you can use it several times in your code. So in fact, I cannot understand what does ABA means, for example. And this looks like kind of abbreviation, of something, but I don't know what it is. And then so in this case I do not understand. And if I use it several times, then those who read this logic will not understand what does this ABA means. Of course, you can write the write the comments every time, but again, you will need to write these comments as much as you use this ABA, and this will not be so efficient. But what you can do, you can define a constant final string, and this will not be the type. This will be maybe the only waterfront in Google, that would be applied behavior analysis, for example, ABA. We name it as ABA. So this is the key. This is this may be the key of the value. And then if I use this value inside the code, I can use this constant. So in this case, every time I use ABA, I can understand that this means applied behavior analysis. So we just don't use this key, but we actually use the constant. So in this case, I will always understand that the type, which is actually ABA, this is applied behavior analysis, just as an example. But there can be any abbreviation, and just show the example that we can actually understand what is hidden outside this key, this abbreviation. And I don't need to write the comments every time. Right, so this is about the constants, and so then we can quickly go through the primitive types. In Java, as you know, we have two ways of data storage, two ways of the types of the variables and constants. So there are primitive types and reference types, and the smallest types, the primitive types are just simple variables which do not store the references, and just only have the values like byte, short, integer, long. So these are integer numbers, then floating point numbers like float and double, and one simple character. This is char, and boolean, like true or false. So, and as you can see here, no more. Only these are primitive types. And as you can see here, there is no string. So maybe those who work with other languages, this may be a little bit crazy that the string is not the primitive type, but this is how Java works. Strings are built. The strings are the objects. Strings are the reference type, and strings is the reference. String is the reference type, and it is built from the list of characters, from a sequence of characters. So about the integer numbers. We can initialize them in 3 ways. Just a simple way how do we usually do is decimal. Just decimal numbers like 2, that's 2, 10, it's 10, and so on. Also, there are octal. We can calculate them. There's the way how we can calculate them, but for our topic, this is not really important. Yeah, this is just the way of storage. In computer science, there are different ways how the numbers can be stored. It can be binary form, it can be octal, hexadecimal, and so on. So in this case, yeah, there are different types, and if you want, you can find how to calculate them. This, for us at the moment, it's not so important, but yeah, there are some different ways values are stored for the integer numbers. And also, as part of numbers, we have float and double. And by default, with a simple number value is double. And subtype of sample can be set explicitly using postfixes like F or F in uppercase or F in lowercase. There's no difference for float. And the same D for double. Yeah. Also, we use exponential form, which is E or E lowercase, and that means 6.02 times 10 in the power of 10. This is how we use it. And the characters, that's 16-bit Unicode character, just one single character, A, B, C, D, and so on. And also the numbers can also be considered, integers, the digits can be considered as the character, so that's just one simple character. And just one thing to understand, we define strings, if we define the value using double quotation marks, like here, then this means that this is the string. If we use single quotation marks, then this is the character. Anyway, so here we can find some unicoding. I can show you a small example. So, for example, we define the string this way. So that should be so this is the symbol, empty set actually. In fact, we can find this Unicode from the table, because I will show you this Unicode. Character table. Let's quickly. Okay, so yeah, for empty set, you just see that. Yeah, so this is for empty set. Actually, I did not use the plus, because it's not needed, but you need to replace the plus with nothing and all the letters, all the characters to lowercase. I think that should not work. Yeah, this should not work. This use the uppercase here. Use uppercase here. But yeah, so yeah, first we need to use /u. It means that this is Unicode character, the Unicode value, and then the corresponding Unicode from the table. So what else can we use? Excuse me. What else can we use? Just select any character from here. Not sure about the emojis, to be honest. I'm not tried, but let's check if we can use the emojis as well. Okay, emoji did not work. Yeah, it's not supported. It's not supported in Java, I guess. But yeah, if you work with simple characters, not just any emojis, you can select any of them. Just some character. And then copy the code after you pass and then /u and you can print it out. Okay, for some reason that did not work. Okay, maybe not all the characters are supported, but let's maybe try one of them. It's maybe something cool. Okay, still. Okay, but for most characters this should work. This should not be a problem. The idea is that we provide Unicodes for the characters. Sometimes Unicodes are really important, not only in Java but in programming, especially for us. As for those who live in Latvia, who use Latvian language encoding, because sometimes you may face the issues with the encoding. Because Latvian letters like A, Ņ, Š, and so on, these are not Latin characters, yeah. Simple Latin characters. These are special characters, and that's why sometimes, in some encodings and some solutions, these characters will not be supported. So in this case, we need to try to figure it out using the Unicode characters, just any type of some type of encoding. And so on. It depends on when you're working in, because in different platforms, in different languages, different frameworks this will work differently, but yeah, that's the point, to be careful working with when you work with Latin languages. Right. Yeah. That's here you can see the table of characters. Yeah, you can select them from here if you want. Yeah. So here you can see how the table looks like. So yeah, the first yeah, so you can select them from here. Yeah, okay, then let's move on. Then we use logical type boolean, which can be true or false. So there is nothing detailed, just true or false. And booleans are used for logical expressions to determine if the condition is true or false. If we compare something, if we check something, then yeah, we have the output which is true or false, and this is what we use. We check if it's true or false. Yeah, here you can see the example, and maybe we can quickly change this class in Eclipse. So the name of the class, yeah, please remember that the name of the class should be the name of the file. Should be the name of the file. Otherwise, this will not work. So yeah, and here you can see the overloading of the function f. So here we have the same function name with the same definition signature, except for the types, for the parameters we provide to the methods. And we have long, we have integer, short, byte. And what happens here? We create the instance of the object, and then we call the function. So when we call the function, we actually provide the same values here, the same value here. This is equal to 117. Since this is long, this will call, since we put L here, it means that this will call the function f where the long should be provided. So this will be called. When we provide nothing, so that means that this is integer. Integer will be called when we cast to short. So we use the casting order for the primitive type, for the number, and then this is the short. Short, and it is passed, and then the method for the short is called. And the last one is byte, and here you can see that it shows minus 37. That's because of the way how the bytes work. So if you see how the bytes are constructed, then there is no range. yeah, the range is from minus 200 or minus 128 to 127. In this case, this is out of range, so it means that converting will not be done correctly. So it is costing to something different what we provided. If we provide something like 5, let's see what do we have here. In this case, if we provide 5, then everything is correct. So that's just because of the type, definition of the type. Anyhow, here you can see the range. We use the corresponding value to the corresponding type to actually, according to the range, we use this file. Usually we use integer because this is the most straightforward type. But also for more simple types like short and byte, we can use that as well. If the value range for the numbers we're working with is not so large as integer, or even more long. So you can see them. And then, in addition to the numbers, these primitive types, there are also first of all, there are wrapper classes. We can shortly talk about them now. In Java, there are different wrapper classes. So, okay, maybe we can. We have primitives. As you know, we have primitives, integer, double, character, and so on. But for these primitive types, we also, let's say for each primitive, in Java, we have the corresponding wrapper class. So it means we have integer, so and here we can assign the value. So this will work the same way as integers work. The difference is class in fact, the range should be the same as for integer, but let's assign the values. So here we have minus 2 billion. Okay, maybe I will assign the values here. So here we have, this will be 1. 2, 1, 4, 7, 4, 8, 3, 6, 4, 8. So this is the value for the integer plus 1. As you can see here, it is out of the range. If we provide this one, this is fine. Right? So this is the maximum value of integer int type. So if we find this way, basically, let's see what happens if we, I think that should be the exception. There should be the exception. Okay. Oh yeah, it actually goes negative. Okay, 5. Yeah, you can see that the behavior is strange here. Yeah, it basically goes negative on the negative direction. So it actually, how does it work? So it means that in this case, if we add 1, this should be minus. So it goes basically on the opposite direction. So if we go to the maximum value and we add 1, it means that it goes back to negative. So in this case, that should be minus, basically the smallest integer. If we add 10, then it should be minus 39. Oh, 3. Yeah, I think that should be 39. Yeah, it's minus. So it basically goes in the opposite direction. Let's see what happens if we do it the same for the integer. So if the value is out of range, it starts from the smallest integer, and then we'll go ahead. Let's see what happens when we do the same for the wrapper class. Then this should be, the behavior should be the same. So behavior should be the same. Yeah, goes to the opposite. So basically, if you use proper classes, then they should behave the same way as the primitive types, with one exception, that for the proper classes you actually have more functionality. Yeah, so since the proper classes are the classes, so it is that there are the methods. So here you can see the instance methods, methods which are linked to the object directly, and you can see the static methods which come from the integer class itself. As you already know, using the integer class we can parse integer from string, for example. If we have, for example, the string provided, then we can parse it to integer and use it as integer. So about the wrapper classes. So first of all, wrapper types have more functionality. Methods. And secondly, wrapper classes can be used as the types for generics. We'll talk about generics later. I already mentioned about generics in previous course, but in this course we'll have more theory about them. We'll create some of them and we'll use them. But yeah, for generics, generic templates, template classes, we cannot use primitives, only developer classes. Okay. And yeah, maybe the last thing before we go to break is yeah, I think we can explain it now. We have the classes like big integer. Oh, this is from Java. Okay, we'll have Java mass from the later. Today, then I will also talk about such objects like big integer and how can we work with them. Okay, right now let's have 10 minutes break and Okay, let's move on. Yeah, so we have the primitive types, and all the primitives in the set can be replaced with the corresponding proper classes. So again, for integer we have integer, for double we have double. Done the same for character. And also they work the same way. Same way, doubles here. Float is here as well. So all the same things. Float, double, boolean as well. So you can use proper classes instead. Okay, so let's move on. Yeah, default values. Also, if you do not assign anything, then by default there are different values for different types. For byte that's 0, for short it's 0 as well. Yeah, for byte, integer and short, these are zeros. For character, that's character 0, yeah, not the value 0, but the character 0. So yeah, that's also important in programming, not only in Java, to use the quotation marks, because the value. So it's not. You should know that 1 is not the same as 1. Right? Should know this. Same as for 1 is not the same as string 1, and also the character 1 is not the same as maybe you can right now we can also show it this way. So if I check 1 equals 1, use the brackets here. Yeah, in case you oh yeah, you cannot even compare them. Yeah, that's obvious. Yeah, that's obvious. Yeah, that's obvious. You cannot compare them. Character and string, because these are two different types. And so please be careful, and you should remember that you should definitely, if you work with the strings and the characters, you should use the quotation marks. If you don't use them, then this means that this is an integer, and if you forgot using it, that this may trigger some serious issues. So that's why here it is highlighted, not in bold, just to distinguish that this is character, not the integer, not the number, not the digit. So yeah, for object reference we have no. That's also true. Yeah. That's how it is for you. That's what it is for reference types. For all the reference types, and just any class you define, any reference type use, the default value will be null. For the arrays as well, and default value is null. So it just means nothing. Yeah. If you try to do any actions with nulls, then you will have the null pointer exception error. But you can also use this as the value, just pass it from one place to another. That it is allowed. But if you want to do any operations like try to call any method from null, then you will have the exception. And that's for all the languages, and not only in Java. In other languages, null and undefined by objects are also exist. Okay. And the next section is about the comments. And in Java we have, as you can see, 4 types of the comments. So first of all, this is single, just one line comments. Just use control slash, and this will comment the whole line. So you put the comment marks at the beginning, double mark, and this will comment out all the line. If you press 1, then this will not work. Use both, at least 2. You can use more if you want. Then if you want to have multiple line comments, then you can simply use slash star and the comment, and this will be comment. This means that the comment is ongoing. This was until the end of the comment. So it means so here will be the start of the comment. And yeah, you need to close this comment, otherwise you will have the errors. And you can close it the same way. And yeah, just before you format it, yeah, this works as well. Yeah, this is fine. But if I format the code, I press Ctrl-Shift-F, then you can see that stars also appeared here. That's because of the formatting. And you can see that now the code is formatted, and yeah. So now all the brackets are in place. So and yeah, this is called formatted commenting type. And what else do we have? We have the commenting for documentation. This is needed in case you. No, I will copy this code. Okay. This one start. So I will comment the code. Wait, this one. Okay, so I will need to this. Okay, and here we also have the commenting for the documentation. So we start with double stars here. And you can see the colors different. This is the Java doc comment. And this should be the end. The difference for Java document is that when we export the file, as Java doc, and then and now Java doc will be constructed. You can see it right here. So here you can generate the documentation for your class, and method examples. Oh yeah, so we have the method examples, and have static methods made, and the comments should be documented, exported here as well. Does not show here. Okay, for some reason, but yeah, that should be generated. Yeah, the idea is that these comments are used in job jobs. But yeah, we will not use it for our purposes, just for information. But these comments are used in Java documentation. I think these should normally be on the top, but okay. Okay, that's not so important for us at this point. Okay, then let's move on, and we have two terms, decoration and initialization. So when we declare the variable, it means that we just we declare the variable. This is the command which shows, which provides the information to the program that a new variable will exist now, and we can use it as well. Yeah, this is what decoration is, and the initialization means that we assign the value to the variable for the first time. So it means that the constants, for example, can be initialized only, but the variables can be initialized and changed after that as well. And in Java, it is usually in programming it is preferred to provide the value to the variable during the decoration. So we need to usually initialize the variables, but we can also skip it. That's not restricted. And use them after that and initialize them somewhere in your code. And if you use the variable which you are not initialized, then you will get the error or exception. You can set initialize this way, and then you try to print it out, and you'll see the exception. So I cannot use the variable before it is initialized. That's an important point. Then the typecasting. In Java we actually have, in Java programming we have the term casting, which is used for primitives and for the objects, for the reference types. But the meaning for the typecasting and the idea of working is absolutely different when you do it for primitives and when you do it for the reference types. And this is maybe a little bit strange thing, but yeah, casting works in fact absolutely in opposite way when we talk about primitives and when we talk about the reference types. For example, like you know that we have integers, we have longs, doubles, floats, and so on. But what will happen if we pass like integer to double maybe, or float to long integer, long? And what happens in this case when we assign different type to the variable? In this case, there's the casting. In this case, and the casting means that it's what I said, that we provide different type. And how it can be done? Basically, casting can be done in two ways. First way is just done automatically when it just makes sense casting, like you provide integer to float. So in this case, we know that all the integer numbers are float as well. Yeah, like if we have 2, then the corresponding float value will be 2.0f. Because that makes sense that the value can be easily converted without any data loss, so everything is fine for us. Comparing to the opposite, if we have a float number like 2.15, and then we want to assign it to integer value. In this case, what will happen? If we want to pass it, what will happen? We can round it to 3. We can round it to 2. Yeah, we don't really know this is not so clear what we always need to do in such cases. In programming, in Java especially, not especially, but in Java in particular, what happens, just if you pass 2.14, then just 0. Basically the floating digits will just be removed. In this case, you get from 2.14 you get just 2. And in addition, this will not be done automatically. Like in this case, if you assign long to in this case you do not have floats, but if you assign float to integer, then you need to provide you need to point to the program that you want to cast. And in this case, the casting will be done. Yeah, it will not be done automatically. You need to manually provide the type to which you want to cast. That's what happens for primitive types. And as you can see, when we cast from primitive types, then we have data loss. Then we lose the data. For example, if we have float, that's a stumble. That's some fun for us at this point. So this would be the value. And then we in this case you can see that by default that provides us exception because it will not be done automatically. So we need to provide a constant operator to point that the conversion is done here. We must point that conversion should be done here. And the interesting thing is the thing to remember about primitives, where we just try to assign in this case you can see that we go from double value to integer, then we pass it back, and we see that the value, the floating parts, decimal digits are lost. Yeah, we just have 2.0. We lost 0.34. So if we go to, let's quickly check the same with the wrapper classes. I think the behavior should be the same. It should be the same. For wrapper classes we have one interesting thing, but I think that in this case the key here Oh yeah, that's interesting. Yeah, so in this case we will yeah, that's really important. It's really important and interesting thing here. When you use the wrapper classes instead of the primitive types, then in this case the casting happens as it is for the objects. Okay, maybe let's talk about it now. So for the primitives, as we've seen before, we can only we can cast both ways, but if we cast from more specific to more general, then we will have the issue. We'll have not the issue, but the decimal places will be lost, and we cannot get them back. This is how the casting for the primitive works. So we lose the data. For the wrapper classes, we cannot do it the same way, because here we have the casting for the reference types, and for the reference types we can only cast from the from subclass to we can cast subclass to the variable which is the same class, which is defined as the same class, or the superclass of this class. So it means that for reference types we can only go from more specific to more general. So we assign more specific value to more general variable, or the same. Yeah. We can always assign the same type to the variable. But for the primitives, we have absolutely opposite way. We cast from if we cast from more specific, like in this case from double to integer, then we have more issues comparing to the reference types. And in this case we cannot convert from double from integer to from double to integer, because this is the class, and this is not the primitive type anymore. This is the wrapper class, and we can cast only if like in this case that would be if double is the subclass of integer, but yeah, in this case it is not defined as the subclass, so we cannot convert. We cannot convert it. But the concept is that in this case we attempt to cast double or integer, and so for reference types, when we do the casting, the value, the reference will not be changed. So this is an important thing to remember for you. When we do for the classes, for the reference types, then when we do the casting, the value will not be changed. It will stay the same always, because this is the reference. When we cast the reference, we do not change the values. When we do it for the primitives, we sometimes, like in this case, when we do it for doubles, we change the value. And in this case, when we try, we can do this one, and this should work. And this one. This should work. Okay, yeah. So we need to do one more thing. We need to do one more step, and let's repeat this for double. So if we do it, this way. Oh, sorry. Oh, sorry. No, that was correct. Double here, and we have. We do not cast it here, but we just use the primitive tag. And okay, so unfortunate. Yeah, that's just because you cannot cast from class to primitive tag. That's not possible to do it directly, but you can do it using double. But what happens in this case? In this case, comparing to the reference types, here what happens actually, a new value is created when we do this operation. So when we actually do such kind of operations for doubles, when we reduce, when we cut the decimals, then we actually create a new number, new digit, or new integer number. Comparing to the references, value will not be changed, but for the primitives, the value is changed. Yeah, and this is also said that sometimes we the behavior may be different, but okay, it's about casting. Let's quickly show these examples here as well. Okay, and this one. So what we see here we have character, but we let's say translate character to integer. And what happens in this case? We should show the Unicode. Unicode. Comment out here, just to not confuse you. So it prints the Unicode. Basically, yeah, what's the idea? Why it printed out the Unicode? Because for all the characters we have the Unicode numbers. And I will show you the table of them. So right now we have the character X. And yeah, so this is a CII table. ASCII table, and for each character there is the corresponding number assigned. So this is really important, basically for the system, how the program sees all these characters, and the characters are stored as the integers, in fact. Yeah? So, and it actually means that every character is in fact it is the integer. And as we just seen for x, we got 120 for x, and for any other character you will have the corresponding integer number. So this is a really important table because sometimes it may be requested, especially if you do some kind of cryptography, if you work with the keys, if you make the keys from the characters. Then in this case, to do some calculations, to shuffle maybe and to hash them, you will need to use the SCI table and SCI characters. Okay, and then you can see some patterns of casting. You can cast some different types. You can cast some different types in between them, but yeah, sometimes this may reduce the content of the values. Like if we cast long to double, some digits will be lost here. Okay. Then the next one is the variable scope. In Java we can define the variables in different places. It can be inside the class or inside the methods. And in this case, inside the methods, inside the loops, basically we have start of the start bracket and end bracket, and we define the variables inside. So based on the scope of definition, the variables are visible inside the blocks. Like if you have the method and you define the variable inside the method, then you will not be able to access this variable outside of the method. Same is for the loop. If you pass the variable there, then you will not be able to access it from outside. But if you have the method and you declare the variable there, then you can access the variable from inside the loop, which is declared in the same method. Like in this case, if we declare it variables in the method, and they are used in the methods only, this is my method. If you declare them inside the class, then they can be accessed from the class and from the object, which is created based on this class. So these are instance attributes. And for the statics, the statics can be always accessed just as part of this class. Make sure why the round brackets are used here. They are not needed. Don't confuse you. Brackets should not be here. So the scope is based on the blocks we define. For example, here we have integer, and also the namings may repeat. Like if we have the class attribute, then you can declare the attribute with the same name inside the methods inside this class. So then these will be considered as different variables. But in this case, that may raise some confusion. So please be careful. And you also in your ID you will see that these variables will be colored differently. Yeah. So in this case, you can see that we have the class, and inside the class we have the variable defined. Okay. So this is the variable available inside the class, and also so this is default. It can also be accessed from outside the object, from outside the class under the object defined with this class. So in this case we have I, which is defined in the class, and we have different I, which is defined inside the method. So it means that if you, in this case, you have I here, you have I here, and if you use I inside your method, then this will be considered as the variable declared here. If you use this keyword, then it means that you are accessing it from the current object. So it means that this is the class, and this is the object, the attribute of the class. And that's why this variable will be accessed here. And right here we have another I. So basically, if you declare the I here, or you declare I here, this will be, in fact, this will be considered in the same way. This will consider the same. And with the on option that this is the parameter of the method, so we can pass the value to this method. But it will be used the same way as I is used if you declare it inside the method. So in this case, in Java, this thing it looks pretty clear. And here is one important point. Again, comparing to different languages, in Java, all the if we have the parameters about the variables declared under the class and inside the methods, that's fine. But if you declare the parameters of the method, then usually in programming we have two ways. In Java we have only one way, but like in C++ and C-type languages, there are two options. The first option is to pass by value, and another option is to pass by reference. Like again, for those who prefer to C++, pass by reference. So for those who work with C++, you will see such thing. You've seen such thing. And yeah, this and symbol. This means here's another example, and this means passed by reference. And what does it mean? It means that you create the variable somewhere, like for example here, and you call the method. You call the method which has the parameter, and you pass this I, for example, like in this case you pass this I to the method somewhere here. And how will it work? This means that the variable is here and you pass it by reference. So it means that the parameter you use here, like in this case, this will be the same variable as as the variable you call the method from. Like in this case, that would be if you did it this way. Then actually in this case, like again, if you pass by reference, not in Java, in other languages, in Java we don't have such option, but this would be this will work this way, that we declare the variable I here, then we pass it here, and then when we use this variable I inside this method, this will still be the variable you declared here. So this will be the variable you declared here, and you use it in the method. This would mean simply that if you change the I variable here, this will always reflect the changes here, because this will be the same variable. and this is what is called pass by reference. So if you actually pass the variable itself, not only the value, but the whole variable with all the properties, with all the things, and this will be just the same variable. In Java, we do not have such option. In Java, we only have the second option, passed by value. And what does it mean? It means that when you call the method, what happens, you actually create a new variable. So the program creates a new variable for you. In this case, this will be int I, created here, and it is used in the program, and you actually pass the value from here. So in this case, you do not pass the variable, you just pass the value of the variable when you call the method. So these are two important points to understand. Pass by value, pass by reference. In different languages, this is very important. But in Java, there is no such way to pass by reference. But how it works in Java? In Java, again, we use the references, and using the object, using the reference, we can achieve that. We can achieve the this result using pass by reference. So in this case we use the objects, and for the objects, again, when you pass the like if you have nothing in primitive type, but the object, it means that we pass the reference to the object. So pass the value, but the value object of the object variable is the reference of the object. So it actually means that we pass the whole object, the reference of the object. But since this is the reference, it means that the reference will be the same both places, inside the method and in the place you call this method from. And in this case, of course, if you change the value in one of two places, then the change will be reflected in another place as well, because this is the same reference, the same object. Right? And so this is about scope of the definition of the variables. And the next keyword is static. In the classes, we have basically the approach we use for the classes. There are two approaches we use for the classes, and it is very important to distinguish them, because usually, and also the people who start working as IT developers, they do not distinguish static methods and attributes from the instance. We call static an instance and non-static. We call them instance, we can call them non-static methods and attributes. Basically, in the real life, how we can imagine? Again, imagine any station, basically any place we can consider as the system as the object. The system as the object, that would be, let's say, again, computers. The most simple example is computer. Like we have the class of the computers. So this is the class, class computer. The object is just a real computer with the serial number, with all the things. Just one single computer. This is the object, and the class is computer itself. Just the computer as the class. The class of computer. So one class may have the endless number of the objects. Like we have class computer, so we can have as much computers as we want as the objects. So this is the class, and this is the object as computer itself. About statics and non-statics. When we have statics, it means that this is what belongs to the class, And non-static means that this method or the attribute, it belongs to the to the object, computer as the object. Like in this case, that would be, like if we have computers, then under the static we declare all the things which will firstly be the same for all the computers in the world, and that would be any object and any behavior defined, any attribute and any behavior defined for all the computers in the world. Not mention all the examples at the moment, but I think you understand that this is basically what what is the same for all the computers in the world. And non-static, it means that it is a part, it's the attribute or behavior defined for each object separately, for each class separately, or for each computer separately. Like I have my computer here, so I have some different properties of my computer currently here. Like you have your own computers, you work on them, you do some things with them, you do some configuration with them, so it means that behavior is different and different behavior, and the properties are different in each computer. And so this is defined by non-static behavior. But if we have some common things here, for example, if we all use the class of laptops, then it means that we have chargers, so we all have chargers for the laptops, so we all have the screens, and the behavior will be that all the screens are on, for example. That's a new example, but yeah, I think that you understand that this is something what we have for all our computers. Like, yeah, maybe if we go more detail, that would be the computer with the exact model. Maybe okay, I can quickly check one particular model. Here, just random model of the computer. So we have the computer with such model. Then we have all the properties here. So what does it mean? It means that the details, default details will always be the same for all the computers, for all the personal computers, something like this. So it means that the static attributes, in fact there is no static attributes because everything can be changed, in fact. Let's say, yeah, that's maybe yeah, about the software. Then software of the computer may be more relevant. Example, like we have the software controlled by the provider, so that maybe it can be the Windows 10. So yeah, maybe the Windows 10, like the Windows as the class of all the Windows configuration. Yeah, like everyone has, for example, yeah, those who use Windows has Windows 10, for example. Then there is the basic configuration done by Microsoft. Yeah. So all the things are the behavior defined by Microsoft, and the properties defined by Microsoft, which are applied for on all the Microsoft Windows 10 computers in the world. Yeah. So these are the attributes and the behavior defined by Microsoft. So it means that if Microsoft does some changes with them, then the changes will apply for all the computers, Microsoft computers in the world. But if you do some personal setting on your computer, on your Windows, for example, then this will not reflect the changes on other computers. And this would be non-static method, like what you do. But everything what is done by Microsoft and it is shared with all the computers, we can consider it as the static static behavior using static attributes. Alright, so let's have the break now and talk to you. Okay, let's move on. Yeah, so we have, let's say we have static attributes. So what does it mean? It means that they belong to the class. These attributes belong to the class, and means that they can be used as a part of the class. So as I just said, when we change these variables, basically, and this is one variable, yeah, each static variable can only be one, this is just one variable located under the class. Comparing to non-static variables, which can be different in different objects. Like in this case, we have serial number. This is non-static attribute, means that it is different in each instance of this class. If we declare it as static, then it is, this is just a variable which is part of the class. This is just one, and it is the same in all the objects. But basically, it's not a part of the object, that's the part of the class. Set. And yeah, so public static attributes are accessible using just class name. Yeah, you can use the name of the class, then use the variable and just do any actions with it. If you are inside the class, then you have two options. You can use the class name, or you can skip using the class name. There are two options. In case you have the variables declared inside the class, which are not, inside the method, then in this case, to distinguish them, you need to provide the class name. If you do not have the variable with the same name inside your, then you need this class inside your class. Like in this case, counter, why the counter is not defined here? That's interesting. Oh no, sorry, that's it. Sorry, public static attributes. Yeah, so the counter is here, static variable. So you do not, if it's inside the class, you do not need it. You do not need to use the class name here as the prefix. If you define it inside, if you define another local variable with the same name, with the name counter, then you need to you need to use the class name to distinguish them, right? But usually I recommend to always use the class name before, even if you are in the same class. That's my point. In my opinion, that makes it easier to read the code. So this static methods. The principle is the same as for the static attributes. Static methods belong to the class, so it means that you can call static methods without creating the objects of the classes. And the idea is the same. We create the method and we call the method from anywhere. And the method is a part of the class, not a part of the object. Quite straightforward, just the method with the logic inside. There is the restriction. You need to understand that it is not possible, like if you are in the class and you have the instance non-static attribute, then you cannot use the salary, like you cannot type something like this, serial number, something. You cannot do it because you cannot use static instance non-static attributes inside static methods. Okay. Only static attributes of the class and the variables declared inside can be used inside the methods can be used inside the method. You can't use the non-static attributes inside. Then you can actually you can access the static methods absolutely the same way as you can access the static attributes, and all the properties you have for the static attributes can also be applied for the static methods. Just basically the only difference we have when we access we have actually two differences when we access the static attributes or the static methods. The first difference is that we can pass the parameters to the methods comparing to the attributes. So we use the rounded brackets and we pass the parameters to the method. So this is the first difference, and the second difference is that for bytes, for the methods without the returning types, we do not have anything to return compared to the attributes, because we know that for the attributes we have the values, so we assign the values from the attributes. For the methods we can have the situation where there is no returning value. Alright, so the next is static initialization blocks. It can contain static block of code which does not belong to any method. This is called static constructor. We call it about static initialization blocks. We did not discuss it in a previous course, but I think we did not discuss it. But yeah, this is just a static block. You can pass any code here. Any code here. Static section. So this is, I would say, this can be called. This works as the static computer static constructor. Will be called once the class is accessed for the first time. And when we access the class, and this method, this section will be loaded. So basically, in this case, it, as I just mentioned, it works in a similar way as the constructors work. Comparing to constructors called when the object is created, but the static section is called when we access the class for the first time. And we use it to initialize static variables if needed. And this is the example. We have static, and we just initialize the static variable from here. Okay. Next we go to conditional statements. This is kind of if-else. When we have expression which is true or false, then we have which results in true or false. Then if this expression results in true, then this part of the code is executed. If this results in false, then this part of code is executed. So this one should be Boolean, and these two can be any, not any, but this return the values. Usually we type it this way, like we have some variable, value 4, and so we can type it this way. Result. So value less than 4. It's true. If it's true, then I can assign the value which is value is less than 4. Otherwise, one is equal to 4. So this is the way how we can use expressions in short way. So this is basically the same if we write the same if we write using if-else. So if value 4 is less than 4, if value is less than 4, then result is this string, else this string. And so this is just a shorter way how we can write this expression. Okay, then we go to assignments. Just as simple, you assign, you have the variables, or the variable and the value. So you assign the value, which can be direct value like 100, and you assign it, then you assign it to the variable. Same way, you can also have the variable, then the value of one variable will be assigned to the target variable. Yeah, you can also use this approach. Define several variables here and assign them this way. It's something different. So you can do it this way as well. So it just means that you assign a variable from a value from the right to left. So it means that all these is that x is 100 y equals to 100 and here equals to 100. So this is also the way how we can do it. Just go from right to left. Used in lots of programming languages, I think maybe, I'm not sure if in all programming languages, but in most, this approach is also used. Yeah. Then we have the statements to control the flow of the program. Again, if we have different paths to go, let's say, then we should control it in some way using if-else, or the cases, or cycles. Like if there's something to be, which needs to be repeated several times, like for loop or while loop, and we use the cycles or the conditional statements to maybe skip some logic. And yeah, for this, for such purposes, we use if-else. Yeah, we can use if-else, and then we have the simple structure of if-else. Please remember that we declare if, and inside if we inside rounded brackets we declare we have the expression which returns true or false. So it means that if it's true, then we go under if. It can also be else if. And then we have a block of code which does some things inside. Please remember that how you declare the code. For example, in this case, it means that imagine that you have true everywhere in this case. So if we have if and else if, it means that if this statement is true, so this logic will be executed. And this logic will also be executed, but this logic will not be executed because this if is already executed. So this will be skipped. If this is basically this statement just leaves separate life, it does not belong to these blocks. But if this statement is false, then it checks this statement, and in fact right now this will work like if this is false, then this will work like if we remove else, so we'll have the same meaning of this part of code. So yeah, if we just have one flow of ifs, let's say ifs, else, then if one of them is executed, if one of them is if one of the blocks is executed, then it will not check all the blocks all the blocks down. Yeah, the same is not the same, but in the same way we can use the switch function. Here we have switch. Inside switch we have the value of what we want to switch. In this case, yeah, that's the variable. It will always be the variable which has the values, and based on the value it has, we'll go to the corresponding case. Yeah. And also please don't forget to use break, otherwise it will just go down and all the statements will be executed. So yeah, but this is kind of similar as for ifs. Case 1, so it means that if the expression 1 equals constant 2, then we execute this block. If it equals constant 3, then this block, otherwise else we equals 3. And break is necessary to exit from successful match and not checking following cases. Yeah, that's true. And yeah. So, and for loops, 4 cycles, we have different options. How can we declare them? This is called C-like. Just I would say the for loops used almost in any programming language. Just three parameters need it to be provided. The first parameter is which we use for the variable, and to initialize the variable which is used in scope of this cycle. So here we just initialize the variable. Usually it's int I equals 0. Then we go to the next, and the next one checks the condition. If the condition is true, then we go inside the loop. If the condition is false, we do not execute the corresponding iteration on this loop. And the last one is the action which will be executed after the next cycle, next iteration of the loop. So usually what we have, the most simple example we have here, int I equals 0, I less than, so that's the declaration, initialization of the variable. Then we have the Boolean expression, which checks if it's true or false. If true, so it's I less than 10, we go inside. If false, we stop, we do not go inside, we just go next to the next statements. And here we increment I, but this will be executed after the iteration. So first what happens, we declare I here, we declare initialize I here, we check if I is less than 10, then we execute the one iteration with I which equals 0, then after the iteration we increment I, so in this case I is 1, and then we go next. So this will not be executed anymore, so next we go here. So just the sequence is first, second, third, fourth, and fifth, sixth, seventh, and so on. And so we go from here to here, then here, and so on until. So yeah, we start with this one, then this will not be used anymore. We go here, and so on. So we go by this loop, and we repeat all these steps. So this step, until this step is false. So once this step is false, we do not continue. Next, we just go out of the loop and do a little bit after that. Also, the syntax we can use for the arrays is for the collections. Let's start in Java 5. We can use such syntax used. As I understand, I know that this is used in PHP, but not sure if it originally comes from PHP. But yeah, we can use such style for the arrays, and it means we just go through all the elements of the arrays. So it means that the concept is not the same as we have here, but we can use it this way. Just again the type of the element of the array, then declare the variable, and we use semicolon and the array itself with the values. Then we just go one by one, and it prints out all the values. Alright, then we have cycle statement while, also can be used for the loops. The concept is, I would say, more simple. Just the expression true or false. If true, we go inside. If true, we continue the loop. If true, we continue the loop. If false, we do not go inside the loop. And the same way would be if we implement the same way as we previously done here. It will be if we increment I by 1 inside the loop. Then check if I is less than 10, so the result should be the same. Then yeah, the cycle to while is kind of the same as for the while, but one small difference here is that this iteration will be executed at least once, because for a while we know that it will be executed once and the expression inside is true, otherwise it will not be executed, but and in theory it may be that this will never be executed, like if this expression is always false. But for do while the block will be executed at least once. Okay. This is the idea. Statement break. Statement break, I think we did not use it so much in previous course, but it is a really important statement. In some cases it is called exit. In other programming languages this statement is called exit. It just means that we have loop, and if we use break, then we go out of the loop. Like if we use while, in this case we use do while, it means that once we reach this point, we finish our loop, and it won't continue otherwise. It won't continue after this is executed. We go out of the loop. And also the similar statement is continue. If break goes out of the loop, then continue just goes to the next iteration. So it means that it will skip all the logic until we reach, like in this case we reach while, and then yeah, it goes back. So it means just we go to the end of the, we skip all the steps in the corresponding iteration. Okay? And the same can be used for loop and for while loop, not only for do while. Yeah, but yeah, it says we will not break the execution of the cycle, just goes to the next iteration. So these are really interesting statement, interesting tools, I would say, tools to use. You can use it in your code. It provides you more functionality. Alright, and then we go to the reference variables finally. So comparing to primitive types, reference types they live absolutely different life. They have totally different properties. Yeah. So these are object variables, and we also call them reference types. So in fact, and in the resources we can call the objects like objects, references, instances of the classes. So they have multiple terms used for the definition. And the idea is that we have we can imagine them as the object, but the idea is that they store the reference to the place where the objects are stored. And so we refer to the memory, in fact. So they do not store the values, like if we have the variables and we assign the objects to them, they do not store the values, but they store the reference, the pointer to the object itself. And the variable of custom object is defined, reference is created, which points to name. So by default, the value of the variable is for reference type. So when the object is created, the reference refers to twice in memory. And for example, as I said, strings are not primitive types, but strings are the reference variables. And really important for the references are really important for the references. I've shown this example before, but this is very important to understand for the strings. String. So I can use the value ABC here, and if I do the same for the second string, I can also place ABC here. So if we print out, if both strings are equal, are the same, then this should be true in this case. This should be true because for each of them we assign the hard-coded value. But what happens when we actually do this? Maybe just quickly before. So this will be A plus BC. Check this down. In this case, that's also true because we do it just directly. But, when we do it directly, this way the result there should be true as well. But in case we do it this way, string one, let's say, and string part 2. So this is BC. And concatenate both parts. And in this case it should be false. This is false despite the fact that the content of both strings are the same. It's the same. So first thing is never compare the strings this way, because actually the values are constructed differently here. The objects are constructed differently here. Like if we assign the direct values to them, like in this case and in this case, these actually construct the same reference. So the references here, the pointers here will be the same, because we actually point into the same place. The places where ABC is stored, the same is here, and the same is here because we just directly. But if we have two strings and we concatenate them, in this case, new reference is created. New reference is created. Thus, the string is not the same as the second string. So, to compare strings. Need to use better method. And this will always work well. So use equals instead of just simply comparing them. Okay. Yeah. So as an example for the references, yeah, as you can see for strings we do not usually use new parameter. That's because this in fact is already in this case user, and this is already the string, this is already the object, so we do not need to create new one. Because user itself, this string is already the object. But yeah, we can also call new the one that actually create a string. In this case, and I don't check it. Let's quickly check it. So if I play this way, and I play this way, and that's the values, the references should be the same. I guess in this case, oh no, that's also interesting. Yeah. So please, yeah, it's also an interesting case because actually right here we create, yeah. So in fact, yeah, like for us, the behavior is kind of the same because we have user value here, user value here, but yeah, actually the references are different. So it means that because the reference is the reference of user string is not the same as the one created using string. So this is also an interesting point. When we call new, we actually create new reference all the corresponding characters on the string. So, how we create reference variables? Again, if this is not just a hard-coded string, then we must call new. New, this is actually the operator which creates the new object and also calls the constructor which builds the object. Yeah. And from the reference variables, what we can do, we can call them non-static methods and access non-static attributes. Yeah. Okay, next we go to errors. Okay, we will not finish this today, but okay, that's fine. We'll continue tomorrow then. Okay, so let's go through the errors and then we will session play and solve the errors. As you know, let's take the structure where we store the elements on the same time. That's, I would say that's not 100% true, because for the reference types, like we store reference types, you know that we can cast but in fact, that's kind of true, but please remember that for the reference types we have super classes for for the objects, and if you declare the element with one class, then you can place the elements of all the subclasses of this class inside this array. So like in this case, it means that if you declare the array with the type object, which is the superclass of all the reference types in Java, it means that you can place any reference, any object, any type of the objects inside the array. Then for arrays we have the name and we have an index for each element, so all the elements placed in the array are placed under the exact element. So we create every time we create an array, we declare the array, and we need to provide the length of the array. This should always be provided. They can be one-dimensional and multi-dimensional. Means that if each, in this case we have n elements, but if we have multiple dimensions, it actually is the same as that for each element we have another array. So this can be called as the array of arrays. So for initialize I'm using form or yeah, so we can also declare them using type, yeah, in the same way. That should be fine as well. Using the type, using the reply. For the arrays, still we have two ways. We can declare them. In this case, you see, you can declare them this way, or you can declare them this way. This is the same. This should be the same. No differences. So we put the practice, but don't put them this way. This will not be correct. For new place and after the type or after the so it's also okay. Usually we have two options like this or like this. How we declare them? Okay. Number of dimensions also can be applied. And if we don't call new, and remember that the arrays are not the primitive types, so it means that these are reference types as well, so the default value is null for them if you don't initialize them. And yeah, how the arrays are created, so you create the array, you declare them, and you declare the variable, and you create the object, the array as the object, you provide the type and number of dimensions, and you can create logic which fills you the array. And yeah, how basically it's stored in memory. So we have the array, which actually has the pointer to the memory, and inside the memory we have all the elements of the array. So that's why when we create an array, we need to provide the dimensions just to see how many slots in the memory we used. Right there. And yeah, how we can assign values to the array, we can just, so the most primitive way would be if we just assign all the values directly. Yeah, but we can also do it when we just use the indexes and we assign the values to the elements of the array. Two ways. Also, also that, okay, as I said, multi-dimensional arrays, but this is actually means that we have for each element of the array, we have another array where we place which are the same arrays. And yeah, how we declare multi-dimensional arrays. In fact, you can see we declare them this way, but we can skip providing a number of dimensions, and it means that, like in this case, for each element we create a new, we define a new array. This is correct, and in addition we can have a situation we have different dimensions for different elements of the array. Yeah, so the first dimension should always be initialized. The second, it's optional, but we cannot initialize the second dimension only. That's incorrect. Yeah. So they can be with regular size, or just for each element it can be the array with different size. But yeah, also we can declare them this way. It means that this is just a two-dimensional matrix with 4 rows and 5 columns. So it means that for all the elements they will be the same. The array for each array will be with the dimensions 5. For each of 4 arrays here will have dimension 5. And yeah, so this is how we start. The arrays start with 0. And Java, in most languages, we start with 0. In some languages, it's possible that the array starts at 1, but in Java and C languages, it always starts just with the result. It always starts at 0. That's because that's the position of the memory at which we want to start counting. We have the pointer to the memory, so the array, that's just the array is the with all the elements which are positioned in this particular sequence in memory. So they have slots in memory. So 0 means that we start at the beginning of this memory. So it means that we start at 0. And resizing, we can easily resize it, but in fact, so here we have one array, here we have another array. This is just a variable where we store our array. That's why if you want to resize, then we actually need to create new array. That's what we do here. Since the arrays are variables, then we can place we can create new objects and just assign them to the variables. Okay, I think we will need to continue to finish with the arrays tomorrow. And right now I will explain, I will just write the explanations about home tasks, how they need to be done. And yeah, then we will meet tomorrow. It's 9 o'clock. So thank you very much for your attention today, and meet you tomorrow. Bye.